Good morning, everybody. Welcome to today's webinar, and it's part of a series that we've been doing discussing kind of this whole modernization of the wireless network. And it's a series that we've been doing for the entire year, and this kind of wraps things up. And really what we're talking about today is kind of the physical wireless landscape that we're dealing with. So we're dealing with a little bit more of the where of these networks and what are we going to actually be doing with that. So we'll kind of give this a couple more minutes to make sure that we don't have any stragglers popping in, and then we'll get things started. As you can kind of see down in the handouts, there's actually a PDF of the slide deck we're using, as well as a couple of other documents that we'll kind of be discussing, some things that will be helpful for you, and some product literature. Feel free to grab those if you'd like. And if you've got any questions, go ahead and pop those in. We got Perry's kind of watching the questions on this to make sure that if you've got questions, we can get them answered. And then also, if we run out of time here, feel free to also email it to us, and we'll definitely get you what your questions are addressed and answered, and maybe that'll add a little bit more discussion to it, but we want to make sure we take care of you. So we'll go ahead and kind of get things kicked off here. For you folks that are on the broadcast here, or listening, or even coming back as this is going to be recorded and on there, kind of catch up a little bit of who Esteem is. So Esteem is actually, we were established back in 1982. So this is actually our 40-year anniversary that we've been exclusively designing and implementing wireless networks. We are actually the manufacturer. So not only do we design and manufacture the hardware, but also the software is also all of ours. And they're all really specifically designed for kind of those severe industrial automation markets. We own all the IP, both on the hardware as well as the software side of things. And we really kind of also design this with compatibility in mind. So the product that you buy today would be compatible with the product that we're putting out, say, in 5-10 years from now. We want to make sure that we build that into the DNA of the product. And so what we're looking for is, once we get in, there's an investment into this product, we run through a life cycle. We don't want to have all of a sudden everything become obsolete. So we do build that right into it. We are made here in the US. We're headquartered out in Washington State. We're manufactured in essentially, our board houses are either in Washington State or in California. What that's really helped with for us is, especially within the last couple of years, is within the supply chain, we can manage a little bit tighter. And so we've been able to essentially have product available throughout kind of this whole crazy time. And kind of look at the products that we do. We actually cover basically both the FCC license frequencies, which is your 150 to 174 megahertz, your 217 to 220, your 450 to 470. Then we also cover the license-free frequencies in 900 megahertz, the 2.4, and the 5.8 gigahertz. So we actually have 7 different products that we manufacture, and actually have everything in stock. So it's something that has been helpful to be able to do this within the US and control our own destiny, so to speak. So as we look at this, we've got a little bit over 45,000 modems in service worldwide. Predominantly, we stick to the Americas, both North America as well as Latin America. We do get over a little bit into Europe and the Middle East and Asia, but predominantly we are here in the Americas. And really kind of where we get involved with this is our major markets that we deal with are kind of your water, wastewater, your oil and gas, mining, material handling, power and energy. Agriculture has become an enormous market for us. Factory floor, and this includes, AGVs, automated, palletizers. There's a lot that environment is changing. And then we also deal with the infrastructure, and that can be whether it's a campus type of an application, or just extending that network, really is what we're looking at. And so we really are involved in those heavy industries. And what we're looking at, and what we continue to see that's common across all of these, and I'm sure you're kind of in the same boat, is that we're seeing now is this digital transformation. we kind of look at these, we're kind of now in this industry 4.0. So we've kind of gone from, the steam powered automated to now all of a sudden we're getting into these cyber networks, right? The IoT, there's different things. So we actually are now moving into this region. Now, what that's really looked like is this transformation from a communication standpoint really is kind of twofold. So when we look at this, we're really moving from a serial-based communication scheme into an Ethernet-based communication scheme within this industry 4.0. So not only are we fundamentally changing that data and how it's structured, but we're actually the physical interface. So we're, like I say, we're going from that device level communication into, really kind of the goal is beyond just moving into an Ethernet-based system, is going into a network system. And so we're now all of a sudden we want everything to be networked as opposed just to a machine level. So when we look at this kind of this connected model that we're operating on today, really we're kind of looking at, on this graphic, if you kind of look at this from left to right, we've got our things out there. These are your kind of your PLCs, your cameras. If you're part of the Rockwell family, this is kind of, your SLICs or your compact logics or your control logics and the MicroLogic platform out there. This is kind of where those devices are out there. Then we need connectivity, and we've got to have ultimately the whole idea of this is to get that data, and then the data itself really isn't of much value unless we can get in and do something with it, kind of the analytic side of things. Again, if you're kind of in that Rockwell family, what we're dealing with is kind of your factory talk, really. So we've got to take that data, get it to where we can analyze it and make actionable decisions or outcomes based upon what we're seeing there. So when we kind of look at this connected model and what does that connected network look like, what we're looking at is we really kind of have these 7 must-haves of a connected network. It's got to be reliable. We've got to have persistent data acquisition. It's got to be secure from edge to edge. It needs to be able to support both layer 2 and layer 3 networks. Okay, there's a kind of 2 different schools of thought. We either want to keep that data on premise, perhaps we want it up in the cloud, or a hybrid of that, or in both locations. It's got to be very scalable. It's got to be cost effective as well as future proof. And we kind of talked about that earlier, is that this is going to continue to evolve. It's going to become more and more centric within this network world now. It's not necessarily an IT, OT world. Now all of a sudden these have got to be interoperable. It's got to be frictionless. So we start looking at this a little bit to where we come into play, and we start dealing with going across big regions or big areas, right? And so when we're actually trying to achieve this connected network and these 7 must-haves across a wide area, really what we're seeing is that requires that we need to modernize that wireless network, whether that's a new one or we need to update the current system out there. And that's really kind of what the whole purpose of this webinar series has been, is addressing these. And when we start looking at modernization, really it's a puzzle that we kind of put together. There's really 2 sides to this. We really need to look at kind of the what. Think of this as your application demands. Is it a serial network that's moving to Ethernet? Do we need to, are we modernizing for increased reliability? Do we need more cybersecurity? Do we need to have, mobile or roaming equipment, involved here? Is this IoT? Is it, we have, kind of that mobile worker or thin clients or, Wi-Fi access? We've got hybrid networks. So we kind of take the what we're trying to do, and then we blend it with the where. And this is going to really kind of be what the heart of today's discussion is the where of it, the physical environment. And this is really kind of broken up into a few things. We've got the distance itself and how that plays into modernization. We've got the terrain, and then we also have kind of that physical RF environment, right? So once we kind of can consider the what as well as the where, that's going to then kind of lead us to the how, or the appropriate technology. That's going to be including things like, what frequency do I use? What kind of bandwidth is it going to require to do that, and which technology can deliver that? Okay, so as we kind of look at this, the first 6 of these sessions dealt with the what, and this was kind of an Ethernet. We're dealing with reliability, cybersecurity, mobility, IIoT, and hybrid networks. And really what we're looking at is that we kind of took each one of these and really looked at, says, okay, if I'm modernizing strictly because I need an Ethernet network, what does that mean? As well as, okay, I need better reliability. What does that mean? So this is what we've already covered. And if you're new to kind of the presentations, or this is your first one or have missed these, you can actually find them on our website there, and you see the 2 addresses there. That we go into further details, and then the sessions have actually been recorded and then put up into YouTube, and then they're available also on our website there. So as we kind of spin this forward now and start looking at this from what we're going to be talking about today, we're really dealing with that distance, terrain, and environment, or the where. We like to call this the wireless landscape that we're dealing with. We'll kind of take each one of these separately and actually go through and say, okay, here's what we need to look at, and to kind of look at as you're designing this or modernizing your network. So the first thing really we're looking at is distance, and that's real simple. It's just basically how far are we looking at between these locations. Now, why we bring this up is we've done a lot of these modernizations, and especially for you folks that have existing networks, these are changing. I mean, the whole dynamic has changed, and what I mean by that is that the frequency changes that range. So if you're coming from an FCC licensed frequency, and again, these are your 150 to 174 megahertz, your 450 to 470, it's the 2 common ones here within the US for telecommunications, that typically had about a 10 to 20 mile range, right? Now, what we're looking at is there's been a shift, and we'll kind of get into that here in a little bit, is that we're going to a license free, and these can be your 900 megahertz, it can be 2.4 gigahertz, and it can be 5.8 gigahertz. Now, there's a couple of reasons, and we'll talk about those here just in a minute, but now all of a sudden those ranges are shrinking. We're going down to, say, a 3 to 7 mile range, okay? So we need to be aware of that, and so just simply moving, we've got to understand that those ranges may be shorter, and there's ways to overcome that, but we want to just kind of walk through this. So when you start looking at it down in those licensed frequencies, why they had better range is really kind of twofold, because we had much greater power levels because it was a licensed frequency. So you actually had to go get an FCC license. They told you how much power you could broadcast. And so that was normally about 5 to 25 watts, was pretty typical for licensed frequencies. We can get a little bit further with that, more power. Today, the unlicensed frequencies or license-free frequencies have a maximum power output of the radios of only 1 watt. Okay, so we start looking at the amount of signal there. Really, that's nothing more than an equation here of how much transmit power do I have, how much gain do I have in that antenna, and we have something called a free space path loss that I'm going to cover in just a second, and then plus the antenna gain. That's going to really, these are the pieces that go into determining whether your connections can be made at these distances, right? So this free space path loss, really what it is it's, as signal propagates out through space, it expands. So the hard thing is with radio or with RF or wireless, however you want to look at this, or you want to get into your head, is that we're trying to give visuals to this so that you kind of envision what's going on, to add to this, because we're kind of dealing with the invisible world. So kind of a good analogy that I like to give is if we take a balloon, and in order to, and as we continue to blow that balloon up to get bigger, all of a sudden that wall is also smaller, meaning we have less impact against that antenna. So we have less energy that's making it to that other side, okay? So as it goes further out, we have a reduction in the amount of power that's reaching that corresponding antenna. Higher frequencies actually have a little bit more path loss compared to the lower frequencies. So your 900 megahertz has a better range than, say, a 5.8 gigahertz, okay? So when we start looking at that and says, okay, so we can't go quite as far, okay? So when we start talking about that issue, is that also data rate compounds this issue is because today's modern Ethernet networks require much more data rate. So to kind of give you an idea, the old licensed frequencies that we could go much further range, we only have 12.5 kilobits per second RF data rate. So you're basically running about a quarter of the speed of dial-up, to give you an idea. Well, that's just not fast enough for today's modern network. So we need to go into those unlicensed or license-free frequencies, which give us now up to 72 megabits, 300 megabits. We need more data rate. And so that requires ultimately more signal. Okay. So to kind of give you an idea in terms of numbers is the older systems we could run, we only needed about minus 100 dBm of signal, and everything in the wireless world is measured in dBm. Again, it's a negative number, so the closer that number gets to zero means the more signal we have. But what we needed is those narrowband networks we could actually make work or get solid communications with only, say, 100 dBm of signal. Well, today what we need in order to get these high data rates is we now need to have about minus 65 dBm of signal out here. So there's a great difference here. And really, like I say, I don't want to go too deep into these different aspects of it, but what I want you to get is don't assume, right? It's the same thing that we hear all the time. It's just because your current legacy wireless network work between locations doesn't mean that it's going to be a straight plug and play. We really need to kind of look at that. I'm going to show you towards the end of this of just how do we actually take a look at that. Okay. Kind of the next one we want to look at is the terrain itself. Say, kind of like we were talking about before, is that these data rates, we need the high data rate, so they're going to compound that issue, because what that requires is that we move these license-free frequencies. Now, as we move into those higher frequencies, what happens is it becomes much more dependent upon line of sight. So you can kind of see in this graphic, down at 150 megahertz, we could live with a lot of line of sight obstructions. This could be, trees, it could be buildings, it could be bushes, a lot of vegetation. That radio wave would actually be able to penetrate and make it through this. But as we continue to go higher, you can kind of see we get about halfway up beyond 900 megahertz. Well, 900 megahertz can live with, a little bit of vegetation, a little bit of signal strength in, but it still gives us up to that 72 megabits of RF data rate for your application. So now this is about where we start to live within our applications of what we need for these wireless Ethernet networks. As we get up into, say, a 5.8 gigahertz, which you can see there at the top, it actually requires absolute line of sight. Anything that gets in between that is going to basically stop the signal, or basically it's going to cause you to lose the connection to that location. Now, further compounding this is not only what the stuff is in between there, or what kind of obstruction you have, is we also have, the reality is kind of the ebb and flow of the land that you're working with. We've got hills, we've got valleys, we've got peaks, we've got not only stuff in between it, the line of sight, but we also have differences within elevation. Okay, so all this has got to be kind of considered when we're laying out that network. So in order to kind of overcome these problems, is really what we can do is that we can add repeaters. One of the benefits of going to these higher frequencies is this mesh networking that we've talked about before. Is now anybody can act as a repeater for anybody else. So we may not have to go through those trees or the buildings, but we can go around it. We may not get over the hill, we may be able to put a repeater up on the top and simply repeat that data. The other thing is those frequencies themselves. We may need to look at dropping down to, say, 900 megahertz, a little bit less speed than the 5.8 gigahertz, but we can get through those line of sight obstacles, right? There's also, for some of these spots that we may not be able to get these license-free frequencies to. Now we can go into a cellular connection and bring that into it. And this is kind of addressed in our hybrid networks, is all this now can be brought into a common network to be able to do that. And there's really becoming very common to have multiple frequencies on a network to overcome these challenges, okay? So we kind of next look at the environment itself. Well, this is really kind of takes a couple different approaches to it. When we're dealing with the RF environment, is what we're dealing with is that, again, like we've talked about, is we've got to get into these license-free frequencies to get the higher data rates. Well, the key there is that these are license-free. And so you're going to have other users out there. You don't have exclusive use of that frequency. So what happens is that the frequency and the channel management is crucial. Now, again, we're dealing with kind of this invisible world. So when we actually look at this, and this is basically off of a spectrum analyzer, and what you can see here is that each one of these colored dashes, lines, spots on here represents energy that's on that frequency. So you're never going to get a clean one. What we're doing is how do we coexist and pick the right channel within a given frequency in order for that to work. Again, I'll kind of get a little bit more detailed into this, but getting some eyes on this is there's a lot of RF energy out there. So where's all this potential interference coming from that I'm going to have to deal with? Well, think about, we're going through neighborhoods and just about every home has a Wi-Fi router. We've got schools, we've got airports. You can even have things like fast food drive-throughs that cause problems out there. They're all living within this license-free spectrum out there that we're sharing. You get down by, a train yard or ports of entry, wireless ISPs. You've got essentially also you could have your own, you call it interference, but your own networks out there. There's a lot of spots that we deal with where, the water department has one frequency and the wastewater has a whole different network. Well, if we're using the same frequency band, we've got to be aware of that, right? So when we start kind of taking this step and says, okay, I've got these other things going on, we've also got to look at the physical environment of it beyond just other users of it. Again, because we're using these high frequencies, they are much more susceptible or there's a greater impact on these frequencies when we start getting into things like rain or snow or fog or dust storms. Things like this are going to have a greater impact. What that does is it reduces the amount of signal that can get through there as opposed to some of the older frequencies. And these aren't necessarily a make or break, but it's something that we've got to be aware of as we're designing these networks, is to basically design your networks with this in mind, that we're going to have times where we're going to lose some signal. Now, for the radio guys out here, this is where we're referring to fade margin, as we want to kind of build in a buffer zone. So if I'm losing a little bit of signal, we don't want to basically lose that link. So we've got to design that into, our system so that we can overcome those challenges. Okay, so kind of brings to that next question, like, okay, so we've got 3 different frequencies within this. So how do we actually choose which one do I use? What's going to be the best one to do for my wireless landscape here? Well, it really kind of comes down to a 3-step process that we go through. Really, the first thing that we look at is kind of an RF network design. And this is something where basically we can take 2 points and do a software feasibility study. And this is going to tell us really 2 things. Number 1, between these locations, how much signal can I anticipate? And then the other one that we're looking at, especially now with these new networks, is how much data rate can I expect on that? It's not just enough to make a connection. I have to have enough signal to be able to support that particular application or that protocol, okay? Next, what we move from there is we actually go to a radio site survey. This is actually a physical on-site analysis. And you basically go out and you validate the software itself. But also this is where we can now go evaluate that frequency of operation to find what's going to be our best channel. We've got to actually go out and essentially sample it and say, okay, this is where we want to go with that. And then we can also use this as, okay, on a map, say something like Google Earth, as good as that is, it is dated. And so there may now be a new apartment complex or a new hospital or a new school that is obstructing the line of sight that we didn't see. So during the site survey, we can also determine, redundant routes or repeaters out there. Of course, then the final step of this is the installation and commissioning. what we're looking at here is kind of to go back and do the same thing when we're testing this. Then we've got to go back and really look at it and says, how does this actually work? Is it the same today as when we were doing our site survey? A lot of times, the procurement process is long within the industrial automation. And so, what started as a project, say a year ago or 2 years ago, now all of a sudden we may have other people on that frequency. We may need to adjust that frequency. So kind of looking at each of these steps a little bit more in depth, and I won't go too far into it, is we've got an RF path analysis tool. And what this allows us to do is to select the frequency and distance and antenna gain and plug them into a dashboard to be able to see what can I actually expect out of this. And we gain these spots just off of going off of something like Google Earth to where we can actually plot and see how far those are, right? And we're also looking at kind of that profile that we need to contend with. So kind of the beauty of what we're doing with this is that we can now take and start plugging in here is we can have our antenna heights, antenna gains, distance, what frequency we're operating at, and really what we're looking at here, and it may be tough to see on this, but here's how much signal we're anticipating is in this column here, okay? And what that's going to do is basically it's going to show here's the RF data rate that I can expect and what the equivalent of that is in actual throughput. Remember, RF data rate is moving data from A to B between the two radios, but what we're looking at is how much of your data can it accommodate out there. We've also done is actually color coded this to basically green means this is going to be good. Red means it's not going to work. So what this would tell us is this link, we would expect an RF data rate of 57.8 megabits, which is going to equate to 28.9. Okay, it's a tool that you can use. Now we have this up available on our website that you can download, and really it's an analysis tool. So it's up in our utilities page, and there's a couple different ways you can get it. If not, we can also send you a link to that. What this is also going to call attention to is something that's called a Fresnel zone up here. And what that is kind of this, as this energy is going out, we kind of have this ellipsoid pattern, kind of this football shape out here. Well, not only do we need to be above the line of sight obstructions, those antennas, we've also got to keep this clear in order to keep that data rate up, okay? So, and the higher we go in frequency, the smaller that ellipsoid pattern is, but what this tool is also gonna tell you is what that Fresnel zone is we need to keep clear, which is right here. So this particular one, if you can't see, this is a 4.5 mile link at 900 megahertz. That Fresnel zone is 48 feet. So what that would tell us is we need to mount those antennas in order to get the best possible signal and data rate 48 feet above anything in between, okay? So what this also does is you can actually compare this and look at two different frequencies. This is the exact same link. This is running at the 902 to 928. This is actually up at a 4.9 gigahertz. But we can actually now say, okay, based on this, now we can make an informed decision rather than just guessing because this is what I can get my hands on. What's going to fit your application the best? Okay. So then from there, what we end up doing is that we move from there into the site survey. Now, what we actually do is you can actually take a spectrum analyzer and go out and measure how much signal you've got. We can anticipate. Now, what it also does is going to show you all the different channels out there. Now, any spectrum analyzer can do it. This actually happens to be a product that we make called an AirScope that allows you to do this with any laptop out there. What you'll see is on the left side here is that you have the frequency, you're showing how much energy is out there at any given time, basically the amount or the level of it. On the right-hand side there, what you're looking at is essentially kind of a heat map or a duty cycle. So we want to see how often are those channels occupied. Because really that's kind of the key is we want to find out how much interference and then or signal do I have and how clean is that. And you can actually record these and then generate a report, which is shown here under Analyze File. And what that brings us is essentially you can generate some PDF reports that you can look at. That says, okay, at that same exact area, this is what 900 megahertz looks like. This is what 2.4 gigahertz looks like. And then this is what 5.8 gigahertz looks like. So again, this is duty cycle on there, and then you can actually look at amount of signal here. And then down here is actually shown in which channels those correspond to, those different frequencies. So looking at this, if we're going to go with 900 megahertz, we know we want to be down on these channels. They're very open. 2.4 is going to be quite busy, but if we need to use 2.4, we definitely want to be down on these channels or out here as opposed to right here in the middle. Same thing with 5.8 gigahertz, because we've got all these channels down here that are nice and clean. Let's avoid these ones, right? We want to, again, how do we make the best informed decision on this? And that's going to be done in this site survey. Okay. What we're also looking at, and I know I'm getting really short on time here, is we can help you with this. And if you're ready to modernize your network, we can definitely help you. And so, like I mentioned, we actually have 7 different products out here ranging in from 150 megahertz up to the 5.8 gigahertz, as well as a cellular option. And then what we also have is we have engineering services, and we can come out and do basically an audit of your existing wireless network and said, okay, here's what we have. This is what we need to do. We can do the RF network design for you. We can walk you through that. We can come out and do the RF site survey. We can even come out and do the commissioning. Again, we want to help you kind of make that leap into, kind of that modern network that we have going here. Okay, so if you've got any questions, we've got just a minute or two here. If not, please feel free to shoot us an email or give us a call. My email address is up there. You can go into a marketing or a support box and do the same thing as well. Also kind of note down there on the bottom of the website, there is kind of the whole package of this modernization. Maybe, we want to look at a couple things and you can go back in and review this and find some further details of how does that fit into your modernization plan. And I thank you for joining us today. Look forward to hearing from you, and be sure to give us a call if you've got any questions. Thanks.